I wonder how far away I should probably put this. Welcome back to the channel, guys. A few weeks ago, it kind of hit me that instead of just stabbing in the dark with random things, I should probably pick what I want to do and just, focus on it. So I thought I should probably look at the kind of audience that I already have and just kind of cater to that. So with all of my viewers being about 18 to 25, I thought what better content to make than commentary over surf maps in CSGO. No, I'm just joking. Welcome to my educational series that will debut with my discussion of polar coordinates. The first kind of problem we're going to focus on is finding 3 different pairs of polar coordinates that name the same point. Starting with question 21, we should start by creating 3 blank coordinates that we're going to fill out as we go. With our current x being -1, we're going to want -1, 1, and 1. For our y's, we'll have to add 360, giving us -120. So that's going to be your first y. And then you're going to, for the inverse ones, you're going to want to add 180. I said add 180. Yeah, and you get -60 as your second point. You're going to want to add 180 again. 180 again. 120, but we already have 120, so we're going to add 180 one last time, giving us 300. So yeah, these should be your 3 right points, and as long as they're within this little requirement that they have, yeah, these 3 points should be your answer. The second kind of problem is finding the rectangular coordinate for each, dang, I spelled each wrong, you won't see that, of the polar coordinates that we're going to go through. Alright, let's start by naming what our x and y should be. X should be r times the cosine of theta, and y should be r times the sine of theta. This is our r theta. Now I'm going to find the cosine and sine of that. This lists that the cosine is 1/2. That's the cosine, that's the sine. And now we're just going to write down the cosine. And I'm just going to multiply, so I'll just put the 5 right on top. See? Easy as that. And that's our x. I gotta go find the y, which is cosine is √3/2. This times 5 by that bad boy, and well, just as easy as that. There is your I forgot negative. There's your answer. See? Easy as pie. Hardly needed explaining. The third kind of problem is expressing each complex number in polar form. Alright, so let's start this one by listing r as the square root. R is the square root of 3 squared plus √2 squared. But the square root and the square always cancel out, so you just have 9 plus 2, giving you the square root of 11. Just write that bad boy right there. And yeah, alright, now you're just gonna find that the theta is the tangent of, wait, that's not right. Hold on a second. The tangent of theta is your y over x, which is 3. Now you're gonna take out your handy dandy calculator and find the inverse tangent of the square root of 2 over 3. 25.2. Now you're write the cosine of 25.2 plus the sine of 25.2. Now I know that I did write this wrong. I'm looking back at it, and I'll take full responsibility for that. Now the last one is just basically doing the exact opposite of what I just did, and now you're gonna, well, this is probably the easiest one, or at least I think it's the easiest. You're gonna do exactly what it says. You're gonna find the cosine of pi over 2, which is, well, 0. So you're gonna write down 0 plus the sign of pi over 2, which is 1. So you're going to write down 1 I. And you're going to add your 3 on the front. And now you're just going to easily distribute. 3 times 0 is 0. Plus 1 times 3 is 3i. And now you can just add these bad boys together and you get 3i. See? Even easier. Well, that's basically all I know about polar coordinates, so see you later.